I'm taking a sample of sludge. We do this almost daily.
Kelly is the operations foreman at the Lulu Wastewater Treatment Plant in Richmond, BC. It's run by Metro Vancouver. He's part of a first-of-its-kind study that's underway here to find the sweet spot of sludge digestion.
This sample will tell us what's going on in these pilot digesters.
Sludge is generated during the treatment of wastewater. And in big containers like this, it's heated and mixed with microorganisms until it breaks down into a nutrient-rich soil ingredient. And biogas is recovered too. Different digestion recipes vary the sludge flow and temperature, and that leads to different environmental and cost outcomes. The big question is, can a hot minute produce the same results as a slow simmer? If the answer is yes, the projected cost of expanding these facilities could be avoided and hundreds of millions of dollars saved. So the hunt is on for the winning combination.
The pilot digesters are much smaller, but they work exactly the same way.
Kelly's sample came from a mini digester, not this 5 million liter one here at Lulu Island. You'll see why in a moment. Here at this on-site lab, constant analysis keeps the whole wastewater plant operational and accountable. This lab also supports the pilot digester project. The staff here are cataloging and analyzing data from the mini digester samples.
Here are your PDF samples.
Awesome.
Everything looks normal.
Oh, good.
Remember, the large main plant must operate as planned, continually, so experiments can't be conducted here.
They bring samples in every morning, and our role is to make sure we perform all their testing and that the data we generate is reliable, consistent, and meaningful. Once we change one of the settings, we spend about 3 weeks making sure the digester has stabilized. Then we will actually collect solid data for about 3 weeks. And that is what is used in our reporting.
Parisa is the project lead, and she's meeting with the team to review results to date.
It's a really unique opportunity we have in Metro Vancouver, and we are really excited to share whatever we're learning here.
Time and temperature are the key variables.
So we've got some interesting results from what's happened this week.
We have learned that we can meet the performance requirements of anaerobic digestion with multiple configuration and processes of temperature and retention time in anaerobic digester. So it's really important because all of the design and expansion of anaerobic digesters everywhere else in the world is based on the historical data, and it's just based on some theoretical data. Here we're producing some real-time data.
So in the last couple of years, we've gone through several experiments now. Within each digestion project, we change the parameters and settings within, so we could be putting sludge in at various times of retention.
That's all about connecting the technical stuff with the business needs.
Needs such as a growing population and its wastewater.
We simulated population growth in our mini digesters to see how our digesters respond.
They're finding shorter digestion times and increased flows work well. That could potentially delay costly infrastructure expansions. Kelly is headed back to do another system check on the pilot digester. It's composed of 3 small vessels that replicate the full-scale digesters, which must continue providing routine operations.
We've seen some interesting stuff, especially when we've converted from a 38-degree digester and we convert it to 72 degrees. It's pretty exciting knowing that you're able to do experiments that other places can't do.
You don't really see the excitement until you sit into these meetings, and once you start collecting meaningful data, then you see the trending and the full picture of everything. That's when it seems exciting. You're like, oh, that's why we made these adjustments.
We're all working together to make sure that the pilot testing program can bring more value to Metro Vancouver.